It is interesting to note that all the syntax that we have in this code, and specifically this part that we're using to access characters in memory, is dating back to 1971, where the C programming language was officially available for programmers, and its history is based on the B programming language and BCPL, and BCPL has its roots in assembly. Now, C gave birth, or was used as a foundation for C++, which gave foundation for Java syntax, and later C#. BCPL stands for Basic Combined Programming Language, or before C programming language, as programmers joke sometimes. So instead of using the syntax that we've tried to use in our code, it was using an exclamation point to indicate a combination of the base memory and specific location relative to that base memory address. In this next demo, we're making a couple of modifications to the first version of our program. What we do is that instead of forcing address of character H to be an integer, we already know from a previous video that string literal in C and C++ returns the address of the first character. So what we're going to do now is more appropriate, is to use the location, which is a pointer to a character. And of course, we know already that the latest standard of C++ would also require us to make this a constant pointer. So now this location its type is modified to use appropriate type, telling compiler that now this will be used as memory address, and therefore we use this type modifier, which is a pointer to a character. In other words, location is a pointer to a character, and it is initialized to contain address of the first character in this character literal. So then we also change our loop to first modification here that we're making. We just simply no longer need to indicate the type of location, because location itself now became a special variable that already knows that it's designed to point to characters. So now from this declaration, the actual notation is greatly simplified, is made much more readable, and now it's just plain vanilla use of address, which is combined from the location that we already specified, and memory, which is simply a 0. So we really don't update much of a address. We don't recompute the address, we just take the address of the character. Memory is 0, so 0 plus this address is the same address, and so we're expecting that this code will print character H. Now to the next demo, the next version of our demo. So we keep our declaration of the location just like we did in the previous version, but this time what we're going to do is that we're sort of abandoning the memory altogether and saying that now let's use this location of the first character as a base memory location for the entire block of characters, because most of the time we want to focus on specific memory locations that have meaning in our code and not just arbitrary numeric addresses that we enter directly. So here we know that the compiler will allocate the string of characters, and we're accepting its address in a variable name location. And then what we do is that we now say that we can allow ourselves now look around this location, and we're doing by introducing an offset. So we say, okay, let's get a specific offset from the user. The user will enter 0, 1, 2, 3, 4, 5 and numbers like that, and we will combine this 0, 1, 2, 3, 4, 5 with the base location which pointing to character H. So if I specify location 2, it should be location of character H plus 2, which should be this first uppercase L character. So let's try this sample real quick in our code. Just copy and paste the entire program and modify this demo to be using this. And you already know that the latest standard would require us to declare it as a constant pointer. So this location now is a pointer to a constant character, which is the type of character reserved for us by a compiler when it deals with string literals. So I build this program and run it by pressing Ctrl F5 inside Visual Studio. So now it prompts for an offset, which is this offset right here. I'm waiting for this input, and let me try offset 0 first. So you can see that it's printing character H, and actually it has a break statement right here, so the program just exited instead of letting me explore other places. So let me change that. I'll remove this break statement from the program. I'd like to continue running and enter new offsets. Rebuild. So once again, just the same code. The only change I made is added const modifier right here, and also remove the break statement so that I have this endless loop to run. Okay, so this is a new version of the program. Again, I will say 0 and it prints H. I will say 1, it prints the next character, the next character, the next character, and so forth. So you get the idea. So this is much better approach, and now it's quite manageable, because instead of looking at some random memory available to us, we're really focusing on the string of characters, and we're saying, okay, what is the syntax to access specifically individual characters in this block of memory reserved by this literal string. Because it's allocated somewhere in memory, we can now specifically go to each location that we know and try to, in our case, print individual characters on computer screen.